So this is unit number 4 and 5. We are considering lecture number 26. It is only for the revision purpose. What is the local optimization? What is the local optimization and where we will apply this local optimization? So far we have already discussed about the optimization. What are the different techniques of the optimization? Now here we will apply optimization at local level because we divide our source code, that is the source program, into number of basic blocks. So for the simplicity, we divide our source code into number of basic blocks and we will do the nomenclature as basic block 1, 2, 3, 4 and so on. Sometimes we do not write BB1, BB2 like this and just we indicate this by B1, B2, B3 and so on. So our first target is to divide our source program into number of basic blocks. Okay. Now we can apply the optimization at local level. That is, we will apply optimization at each block, at block number 1, block number 2 and so on. How we will achieve the optimization? For that, first we will construct the DAG, that is the directed acyclic graph. Okay, it is like the syntax tree. So far you have already drawn a number of syntax tree, okay, at the parser level. Whenever we were doing the syntax analysis, then during that period we had already implemented a number of, we have already drawn a number of syntax tree. So you have the idea to draw the basic syntax tree. Okay. So with the help of the syntax tree, we just check the grammar of the source code with the help of the syntax tree and we check the authenticity of the particular statements. So far, directed acyclic graph, we can say it is a compact form of syntax tree or parse tree, but it is little bit different than the syntax tree. Okay, so directed acyclic graph we used to optimize our source program at local level, that is within the blocks. Okay, so compiler first divide the source program into number of basic blocks. Now we can apply the optimization within the blocks. So at local level, we can also apply the loop optimization. Another is called the loop optimization. So first we will concentrate over the local optimization. If we have a number of statements or we can say expression, then first we will check whether there is a repetition of sub expression or not. If there is a repetition, then we first eliminate those common sub expression. Then this is called the common sub expression elimination. It is one of the best technique of optimization, and this technique we will apply at the local level or the block level. Now, what is the optimization at basic blocks? So we have already seen we can apply a number of transformations can be implemented by construction of the DAX of basic blocks. So at each basic block level, we will design a DAG. DAG is directed acyclic graph. It is a very, very compact form of syntax tree. Okay. whenever we are going to draw the directed acyclic graph, then first we will remove the common sub expression. Okay, we will also remove those statements which we have involved during the using loops. Okay, whenever we are using a number of loops, then first we will check, is there any statement which is going to repeat again and again. Okay, then first we will take out that statement out of the loop. So whenever we will take out that statement out of loop, then we can say the optimization at loop level. Now we will use the DAX to optimize at basic block. Now we can see what is the criteria, how we will define the tag. Okay, what is the tag representation at basic blocks. Then the directed acyclic graph, it have number of leaves. Okay, then those number of leaves we will labeled with unique identifier. Okay, first we will check during writing the statements there are involvement of number of identifiers. Okay, whenever we will write any program, source program, then there is an involvement of a number of identifiers or constants we will always define, and operator symbols. Okay, so there is the involvement of identifiers, operator symbols during writing the source code. Then, whenever we are going to draw the directed acyclic graph, then leaves are labeled with the unique identifier. Okay, unique identifier are the variable name or the constant which we will define during writing our program. Now there are also interior nodes. Okay, because whenever we will draw the directed acyclic graph, then there is the involvement of the nodes, edges. Okay, or we can say the leaves. So outer leaves, that is the outer nodes, that is called the leaves. Then we can define and we will check. Okay, and we will do the nomenclature. We will assign the unique identifier. Interior nodes, we also have some operator symbols. Then we will assign the different operator symbols to the interior nodes. We will see in the forthcoming examination how we will assign the operator symbol to the interior nodes, how we will assign the unique identifier to the leaf of the directed acyclic graph. Okay, so we will see in the example. Now, what are the edges? Edges are used to connect different number of nodes. Okay, nodes are connected with the help of the edges. Okay, so you have already idea about the basic structure or organization to draw the syntax tree or the directed acyclic graph. Okay, actually you have already studied regarding the syntax tree and the directed acyclic graph, maybe in the data structure in your second year. So I think you have already aware by this terminology, that is the leaf and the interior node and different edges. Okay, so interior node represents computed value. So one by one, there is a root node, and after that we will divide the root node as the children node and so on. Okay, we will divide again and again. Ultimately, we will get the complete directed acyclic graph. So in this case, we will try to reduce the number of nodes as well as edges. Okay. So whenever we will reduce the number of nodes, it means just we are going to reduce our some statements that are repeating again and again. Okay. Why do we use the directed acyclic graph? Because we want to reduce our source program. Okay. How we will reduce the source program? Just first we will check whether there is a repetition of some statements or not. Okay. We will check there is a repetition of some common sub expression or not. So
I want to give it back. Give it back. No, you I'm strong.
we will
I'm not very strong. I'm not. You got it now. You got it.
now
कभी भी पढ़ती आपने भी
come to the
पर आप किसी का
left
भूल नहीं बनते दे रहा है
side
उससे
there.
अपने उसका
Consider one of the example for the better understanding.
आप step back नहीं करो. You will give it back slowly. Just use it.
Please off. Just there is a lot of disturbance. Mute, please. So now we can check here the DAG for the T1 is equal to 4 star I. Please mute yourself. T1 is equal to 4 star I. It is one of the statement. Now you can see. It is the basic example for the directed acyclic graph. So please try to understand this. T1 is equal to here 4 star I. Okay. Now you can see this is the temporary variable T1. Just for that T1 is equal to 4 star I. Now you can see here T1 will come here. Okay. This is the root node. This is called the root node because there is the involvement of only here 3 nodes you can see and 2 edges. Okay. Now these nodes are connected with the help of edges. These are called the different edges. Now you can see here 4I. Okay. 4 star I. This is the tag for 4 star I. Now we can consider the basic block. This is the first basic block 4 star I. This is the complete one basic block. Here you can see this is the separate statement. Okay. T1 is equal to 4 star I. This is one of the separate statement here. Now for this separate statement, how we will draw the directed acyclic graph? Now you can see here 4 star I. Now we have already defined T1. T1 is the temporary variable. So T1, this will come as 4 star I. Okay. Now you can see here. Similarly, now just read these statements. T1 is equal to 4 star I. T3 is equal to 4 star I. Means there is a repetition. Okay. Suppose we have any expression 4 star I plus 4 star I. What will you do? Okay. Now consider T1 as the first temporary variable 4 star I. Again you can see another variable T3 4 star I. Then we can say here T2 is equal to T1 plus T3. You can also change the nomenclature. Just I am considering the basic examples. Okay. So that you can understand how we will draw the directed acyclic graph. So don't confuse. You can choose any name, temporary variable names here. It is not necessary. These are not fixed. You can also consider here T2 is equal to like this and T3 is equal to T2 plus T1. Okay. T3 is equal to T1 plus T2. You can also consider and you can change the nomenclature. Okay. So this is not fixed. You can consider any temporary variable. It is up to you. But whenever you will consider or change the temporary variable name, this structure will be changed. Okay. Here nomenclature will be changed on this structure. So don't be confused. Now consider T1 is equal to 4 star I. Okay. T3 is equal to 4 star I. T2 is equal to T1 plus T3. Now for this basic block, or we can say for these statements, the directed acyclic graph is this. Okay. Now come for this T1 is equal to 4 star I. Just I am copying this. Okay. T1 is equal to 4 star I here. T1 4 star I. Okay. Now here we can write T1 temporary variable 1. You can write different operator symbols inside the node. You can define different operator symbols involved in the statements. You can write inside the node. Okay. So T1 here 4 star I. Now come again. T3 is equal to 4 star I. There is a repetition here. Now we can write T1 comma T3 because this material is same. Okay, 4 star I same for both common sub expression. This now you can check 4 star I, 4 star I again. So no need to write here 4 star I again and again. Okay, just put the comma and write T3. Okay, if there is again repetition, maybe T4 again 4 star I, then you can just put the comma and write T4 again. If the statement is same, that is called the common sub expression. So here with the help of the directed acyclic graph, just you are removing the redundancy. Okay, just you are compacting your syntax tree here, so that our target is to reduce the memory requirement. Okay, it is better that our program must occupy less memory. So first the compiler will check and remove the redundancy in your program. Okay, what type of redundancy? Means repetition of some expressions, that is called the common sub expression elimination. Another type of redundancy means loop optimization. How we will do the loop optimization? Just remove those statements for which there is no need to repeat or write inside the loop. Okay? If there is no any effect over the loop, then you can extract those statements which were written by you inside the loop. Okay, so first you have to extract those statements and put outside, just write outside the loop. So that is called the loop optimization. Now here you can see already, just there is a repetition of T1 T3 here again. Now you can write here is T1. Okay, now here you can write comma T3. Hope you have already understood this. Now here again come to the third line. T2 is equal to T1 plus T3. Okay, now come to this side. Here the T2 has connectivity with T1 and T3. So just write here plus because this is the plus sign T1 and T3. Now you are going to connect T1 and T3. You are going to add T1 and T3. So just write here, just add another node, new node, and put the plus sign here inside the node and then connect with this. Okay, and again put this arrowhead here because you are going to add T1 and T3. Okay, and right here T2. So this T2 for this node. Okay, T2 for this node. So T2 is equal to T1 plus T3. T1 T3, this is going to add with this. Okay, so this is the very compact form, and this compact form, here we have already removed the redundancy. We have already removed the common sub expression, that is called the common sub expression elimination. So this forms the directed acyclic graph. Now you can see this compact form. Okay, so this is called the directed acyclic graph. So this directed acyclic graph, this is used to remove the redundancy. Okay, now come to this another new example here. If I less equal to 20, go to L1. Okay, L1 is the label. Okay, just you are going using a loop statement. This is the if statement, and within the if statement you can see here I less equal to 20. So less equal to 20, then go to L1, jump to L1 here. Now you can see the condition is I less equal to 20. Then put this operator symbol here. Okay, less equal inside the node like the plus minus multiplication. So we will also put these symbols inside this. Okay, less equal this operator you can now put assignment operator or less equal to different types of mathematical operators. Now you can see here less equal to will come in the new node here, and condition is I20 here. You can see I20 less equal to inside the node. Okay, now you can see here the label is here, the label is T1. Similarly, again repetition, then label increased here T3 due to repetition. Okay, here in the third line the label is T2. Okay, so T2 is equal to plus addition of T1 and T3. So this will come here. Now you can see less equal to here go to L1. The condition is saying jump to L1. Then here write like these temporary variables. Here you can, in case of the loop optimization, you can write here label. Okay, so the label will come here. Now this is the directed acyclic graph for I less equal to 20. Here you can see this is the given statements. Okay, hope you have already understood this. Now you can draw easily the directed acyclic graph for this. Okay, so such type of basic statements and such type of loops that may be asked in the examination. Draw the directed acyclic graph for this basic block. Okay, for this basic block. Then you can draw this, the compact form. Okay, so in this case, the memory requirement will be reduced drastically. Okay, why do we use the directed acyclic graph? Because we want to enhance the speed of the compiler. Okay, we want to implement the efficient compiler and want to reduce the memory requirement. So for to achieve such type of, you can say the advantages, we will use the directed acyclic graph to get the better optimization. Now you can see how will we achieve the construction of directed acyclic graph for the basic blocks. Now you are already aware what is the basic block. Basic block, we will implement the different basic blocks from the our source program. Whenever we will divide our source program, then we will get the number of basic blocks or simply blocks. Okay, so now you can see here the construction of directed acyclic graphs for basic blocks. Now the input is here, the input is basic block. Now we can represent it by capital B. Capital B represents basic block, okay, or simply block. You can also call it as block. Now in this case, just for the input we are going to divide our source program into number of basic blocks. Now the output, what is output? That is, we will get a complete directed acyclic graph. Okay, output is a complete directed acyclic graph. With the help of the basic block, you are going to draw the directed acyclic graph. Okay, now there is a, you can see number of points which will involve, that is called the as a information for the directed acyclic graph. Now here you can see a label for each node. Okay, here first we will write a label for each node. Number 2, for leaves the labels are IDs or constants, identifiers or constant. Now you can divide your nodes into number of leaves, that is called the sub nodes. Okay, or children nodes. So leaves are called the children nodes. Now you can do the nomenclature and you can assign the different names to the leaves. Okay, and names are of identifiers or constants. Now come to the third point. For interior nodes, the labels are operators. So we will write different operators for interior nodes. You have already seen. Okay, this is the, here you can see children nodes or leaves, and this is the root node or the parent node. Here this is also called the interior nodes. Here whenever our graph is, you can say, vast, then this will come inside sometimes and you can assign like this. Okay, this is the complete, here the directed acyclic graph, and this is the interior node, and this interior node may contain the operator symbols. Now this is, you can see here, plus, star, less, equal. So these are called the interior nodes and these are called the leaves here. Okay, so at point number 3, for interior nodes, the labels are operators. Now you can write the different operators name which are involved during writing your statements. Okay. Number 4, another point, for each node a list of attached IDs, identifier. So you must have a list of different identifiers which will involve during writing our source code. Okay, within the basic block. So at each basic block level, we will apply the same information, and finally we will draw the directed acyclic graph for each block. Okay, so in this case, you can see how will you construct the directed acyclic graph. So this is called the basics. Now there is a sort of, you can say, a algorithm how we will construct the directed acyclic graph for the basic blocks. Now data structure and functions, here you can see node. In the preceding case, preceding slide, you have already understood how will you draw the directed acyclic graph. Now this is called the algorithm to draw the or to construct the directed acyclic graph. So this is the basic data structure. Label. What is the label? Label of the node. Okay. So this is called the label of the node. We will give the new name to each node and we will assign the different label. Now what is the left, right? Okay, left means left children or left leaf. Similarly the right leaf. Okay, now for each left and right, you can see pointer to the left child node, pointer to the right child node. Okay, list of additional labels. If there is a need, then we can use more number of labels for the empty leaves. Now you can see node here, just we are indicating as ID. Return the most recent node created for ID, else return undefined. Create ID LR, create a node with label ID. Okay, first we will draw the label with the help of the identifier. Now you can divide it as L, that is the left child, and right child. L and R are optional parameters. Okay. So in this way, you can construct your directed acyclic graph. Now in the next slide, this is the basic algorithm which we will use to draw the directed acyclic graph. So there are number of cases, and this is the basic method. So go through this, and here just we are going to divide our algorithm as the type 1, type 2 and type 3, and we will proceed with the help of this method. Okay, and now we can easily construct our directed acyclic graph. So this is the sort of algorithm to for the construction of the directed acyclic graph. Again, there is a type of the directed acyclic graph, how we will construct type 1, type 2, type 3. So please remember this algorithm. Okay. So first I am going to take your attendance here because the time is going to be complete. Now any question if you want to ask, or if you have any query, then you can ask me, please, if you are listening to me. Any question, please?
सर ये टॉपिक यूनिट 5 का है।
हाँ, यूनिट 4-5 एक्चुअली आपको मैंने बताया था, यूनिट 4-5 जो है वो आपका मिला हुआ है, क्योंकि बहुत से टीचर यूनिट आपके 4 लेके चल रहे हैं, बहुत से 5 लेके चल रहे हैं, तो हम भी इसी तरह से चल रहे हैं, क्योंकि ज़्यादातर मर्ज कर दिए गए हैं।